Tonight, as the stars quietly twinkle above and the world softens into silence, let us wander together through the gentle currents of another great idea. This is not the story of gold or kings, nor of war or conquest. This is a story of thought, of code, and of a world reborn through trustless systems. The tale begins not in fire, but in quiet brilliance, in a white paper, and in the mind of a curious young man named Vitalik Buterin. Introduction: The Seed of Ethereum. Vitalik was just a teenager when he first encountered Bitcoin. He was bright, thoughtful, and fascinated by the promise of decentralized systems. To him, Bitcoin was more than a currency. It was a movement, a way to shift control from towering institutions to the hands of ordinary people. But even as he admired Bitcoin's design, he sensed a limitation. Bitcoin was elegant but narrow in scope. It could move money, yes, but it could not express rules beyond that. It had no room for creativity, for conditional logic, for dynamic interaction. So Vitalik asked a question that would change the world. What if the blockchain wasn't just for money? He imagined a platform that could hold not just coins, but agreements. He envisioned contracts that no one could alter, applications that no one could take down, all running on a network owned by no one and used by everyone. This was the beginning of Ethereum. Ethereum was not a replacement for Bitcoin. It was a complement, a different layer of the same dream. While Bitcoin was digital gold, Ethereum would be digital law, digital infrastructure, digital imagination. It wasn't about trust in people. It was about trust in code, trust in logic, trust that once something is written into the Ethereum network, it cannot be tampered with, censored, or corrupted. So Vitalik wrote a paper, a blueprint, a vision, and from that seed, one white paper quietly published in 2013 would grow a network that would power thousands of decentralized applications, move billions of dollars, and inspire a new way to think about value. What is Ethereum, really? To understand Ethereum, let us return to something familiar: Bitcoin. Bitcoin, in its essence, is a decentralized ledger. It allows people to transfer ownership of a token without needing a middleman. It's like a global notebook where everyone agrees what the current balance is. But Bitcoin's scripting language, the code that defines what you can do with that money, is intentionally limited. It's not built for complexity. It's built for security and simplicity. Ethereum takes a bold leap forward. It says, let's build a system that is fully programmable. If Bitcoin is a calculator, Ethereum is a computer, a universal, decentralized, permissionless computer. This computer, Ethereum, can run smart contracts. These are tiny programs that live on the blockchain. Once created, they act like autonomous agents. You send them inputs, and they produce outputs exactly as written. No human interference, no special privileges. Let's say you and a friend want to bet on tomorrow's weather. You could write a smart contract that holds both your funds, checks the weather via an oracle, and releases the winnings automatically. No need for a bookmaker, no chance of cheating. Now imagine using smart contracts for managing loans, creating games, issuing digital art, running entire decentralized organizations. Ethereum enables all of this by providing a blockchain ledger to store the state of the world, a virtual machine to execute code in a deterministic way, a native token, Ether, ETH, to pay for computation. Computation on Ethereum is not free. Each operation costs a tiny amount of gas, which is paid in Ether. This keeps the system secure, deters spam, and ties code execution to real economic value. But why is this revolutionary? because now code becomes law. No longer must we rely on courts or companies to enforce agreements. We can let the network do it. With Ethereum, we can build systems where logic replaces trust. Smart contracts, Turing completeness, and the infinite canvas. Let's take a deeper breath now. You've heard the term smart contract, but what does it really mean? A smart contract is not a contract in the legal sense. It's a program, a small bundle of logic that says, if this happens, then do that. Once deployed on Ethereum, it behaves like a digital vending machine. Insert the right input, and the programmed outcome occurs, automatically, irrevocably. Now here's where it becomes truly powerful. Ethereum's scripting language is Turing-complete. In simple terms, that means it can express any logic you can imagine, given enough time and computational resources. It's like giving the blockchain a full brain, not just a calculator. You can create a lottery that draws winners transparently, a voting system where no one can rig the outcome, a decentralized marketplace that no single entity controls. And these aren't just theories. These are the seeds of what we now call decentralized applications, or dApps. A dApp is like a traditional app, but instead of running on a single company's servers, it runs on the Ethereum network. It uses smart contracts for its logic and tokens for incentives. No logins, no passwords, no corporate gatekeepers. But as with all power, it comes with a cost. Turing-complete languages are more complex. They need more safeguards, more resources. That's why Ethereum doesn't just let you run code freely. Every step you take must be paid for in gas. This gas mechanism does three things. It limits waste. You pay for what you use. It prevents spam. Attacks become expensive. It creates market dynamics. Gas prices reflect demand. So when you use Ethereum, you're not just a user. You're part of a living economy of computation, where every instruction has value and every line of code lives in the open. Ethereum, then, is not just a platform. It is a stage for thousands of stories, programs that run forever as long as one node still breathes. Accounts, messages, and the architecture of interaction. Now that we've explored the mind of Ethereum, let's examine its body, the structure that allows it to live, breathe, and communicate. Ethereum has two types of accounts: externally owned accounts, EOAs, controlled by humans through private keys; contract accounts, controlled by code, not people. Think of EOAs as people with wallets. They can send and receive Ether and initiate actions. Contract accounts, on the other hand, are like vending machines. They respond only when someone interacts with them. They cannot act on their own. But how do these accounts interact? Through messages. A message in Ethereum is not like a chat. It's a transaction or an internal call from one account to another. Each message carries data, Ether, and instructions. When an EOA sends a message to a contract, it may trigger the execution of that contract's code. That code might then send messages to other contracts. This creates chains of logic where one input can ripple through the network. Ethereum's power lies in this ability to nest, branch, and chain logic, all in one unified computational space. This architecture enables complex systems to emerge, multi-step DeFi transactions, DAOs coordinating their own governance game engines that live entirely on-chain. But it also requires careful design. Mistakes in smart contracts are permanent. That's why developers must think like architects. Every line of code is stone set in a public monument. This structure, EOAs, contracts, and messages, forms the nervous system of Ethereum. It allows thought to become action. It allows the will of users to awaken the potential of code. The world computer, Ethereum's state, and the EVM. Imagine a world computer that never sleeps, one that cannot be turned off, cannot be censored, and belongs to everyone. That is the vision of Ethereum, and at its heart lies the Ethereum Virtual Machine, or EVM. The EVM is the soul of Ethereum. It runs the code. It executes smart contracts. It keeps track of everything, every account, every balance, every contract's data. To make this possible, Ethereum maintains a state, a giant map of everything known and remembered. Every time a transaction is processed, this state is updated. Like memory in a brain, it evolves block by block. The EVM takes the current state, the incoming transaction, and produces a new state, just like a machine that takes ingredients and bakes something new. This process is deterministic. Given the same input, it always produces the same result. Isolated, contracts can't interfere with each other's memory unless explicitly allowed. Transparent, every step is recorded, every computation auditable. The brilliance of the EVM is that it abstracts away the complexity. You don't need to understand how every node works. You just write your smart contract and deploy it. The network will do the rest. And the beauty of Ethereum's design is that it's Turing-complete, yet bounded. Gas limits keep things from going infinite. If your contract runs out of gas, it halts. No crashing the network, no endless loops. This is the balance Ethereum strikes. Power, but contained. Freedom, but measured. Expression, but with discipline. Through the EVM, Ethereum becomes a global settlement layer, a neutral space where logic rules and no one can cheat the code. And so, the world computer ticks onward, fueled by blocks, guided by miners, and empowered by dreamers. Fueling the machine, ether, gas, and the Ethereum economy. To power a machine, you need fuel. To run a network, you need incentives. Ethereum's fuel is called Ether, ETH, a digital asset native to the platform. But Ether is not just a currency. It is also a unit of energy. Every action on Ethereum, from sending tokens to executing complex smart contracts, consumes gas. Think of gas as the price you pay to use the network's brainpower. Just like in a car, the more complicated the trip, the more fuel you need. Each computational step in a smart contract has a cost. The total cost is measured in gas, and the user must decide how much they're willing to pay, both in gas units and gas price, in ETH. This creates a dynamic marketplace. When demand is high, gas prices rise. When the network is quiet, prices fall. Users can prioritize their transactions by paying more, or save money by waiting. This gas economy serves many purposes. Protecting the network. It prevents denial of service attacks by making spam expensive. Prioritizing computation. It allows the network to choose which transactions are processed first. Aligning incentives. It rewards miners or validators in proof of stake for maintaining the network. And Ether? It's the bloodstream. It flows from user to miner, from smart contract to smart contract. It gives Ethereum a real economic heartbeat. But ETH is more than just gas money. It's also a store of value for many, a collateral asset in decentralized finance, DeFi, a governance tool in emerging DAO systems. This dual role, both as utility and investment, gives Ether unique power. You're not just buying gas, you're buying a share in a living, evolving economy. The Ethereum economy mirrors our own. It has supply, demand, incentives, speculation, and innovation. But it runs on code, on openness, on rules that anyone can read and no one can secretly change. And just like real economies, it faces growing pains, congestion, scalability, speculation. But unlike traditional systems, Ethereum is upgradable. Through community consensus, it evolves. Ether, gas, and this economy together create the conditions where a decentralized future can flourish. Mining and the road to proof of stake. Ethereum, like Bitcoin, was initially secured through proof of work, a system where computers compete to solve mathematical puzzles. These puzzles are intentionally hard to solve but easy to verify. The first one to solve it earns the right to add the next block and collect a reward. This process is called mining, and it's what kept Ethereum secure in its early days. It ensured that bad actors couldn't manipulate the chain unless they controlled more than half the network's computational power. But proof of work is energy intensive. It consumes vast amounts of electricity. For a global computer that serves not just as a currency, but as an application platform, this raised questions of sustainability. Vitalik and the Ethereum community had long planned a shift to something more elegant, more efficient, proof of stake, POS. Instead of relying on electricity and computation, POS relies on economic commitment. Validators don't burn energy, they stake ETH. The more ETH you stake, the higher your chances to be selected to propose a block. But with that power comes risk. If you behave dishonestly, your stake can be slashed. This change meant 99% plus reduction in energy usage, increased security from economic penalties. A more democratic participation model, anyone with ETH can stake. Ethereum's switch to proof of stake happened in the merge, a monumental event in blockchain history. In 2022, Ethereum transitioned from a mining-based model to a validator-based one, all without halting the network. The merge was like changing the engine of a flying plane, mid-air. And it worked. Now, Ethereum is secured not by solving puzzles, but by locking up value. POS isn't without its critics. It introduces complexity, requires economic trust, and concentrates influence among large stakeholders. But it also opens doors for scalability and environmental sustainability. With POS, Ethereum moves closer to its vision, not just a decentralized platform, but a resilient, adaptive, and future-facing ecosystem. And in that evolution, we see the maturity of the idea, not just code, not just consensus, but an organism growing with care, consensus, and community. Scaling the world computer, Layer 2s, and global dreams. Ethereum's vision is immense, a decentralized world computer accessible to all, secure for all, fair for all. But such a grand dream meets a very real challenge: scalability. In its early years, Ethereum could process around 15 transactions per second. For a network with millions of users, this meant congestion, high gas fees, and frustrating delays. Imagine a bustling city with only a few roads. The destination may be beautiful, but getting there can be exhausting. Vitalik and the Ethereum community knew this had to change, and so began the journey to scale Ethereum without sacrificing its security or decentralization. This challenge is known as the scalability trilemma, the tension between security, decentralization, and scalability. Improving one often harms the others. Ethereum had to find balance. Enter Layer 2 solutions, a class of technologies that build on top of Ethereum to carry much of the transactional load. There are many flavors. Roll-ups bundle many transactions into one, then submit a compressed summary to the Ethereum base layer. Optimistic rollups assume correctness unless proven otherwise. ZK rollups use zero-knowledge proofs to instantly verify correctness. State channels allow users to transact off-chain and settle only the final state on-chain. Plasma chains, child chains that commit periodically to Ethereum. These Layer 2s reduce fees, increase speed, and allow Ethereum to scale for the masses, all while retaining the security of the main chain. And this isn't just theoretical. Projects like Arbitrum, Optimism, ZK Sync, and Starknet are live, moving real value, serving real users. Ethereum itself is also evolving. Sharding is coming, splitting Ethereum state into smaller pieces that can be processed in parallel. Dank sharding and data availability sampling aim to supercharge rollups and reduce costs even further. Through these upgrades, Ethereum is becoming a modular ecosystem, a base layer of security with many specialized highways layered above it. The goal? To support billions of users across thousands of applications without compromise. Ethereum's scalability journey is like building a global city, one block at a time, carefully, without toppling the foundations. Because this is more than a blockchain, it's more than smart contracts or DeFi. It's about giving anyone, anywhere, the tools to build, to connect, to create. And that, dear listener, is a dream worth scaling, the spirit of governance and the road ahead. Ethereum, for all its code and contracts, is also a living community, a digital nation without borders. But like any nation, it must ask, who decides? How do we change? What is fair? This is the challenge of governance. Unlike companies or traditional governments, Ethereum has no CEO, no president, no board of directors. Instead, it is governed by a network of developers who write and maintain the code, validators who secure the network, users who shape demand, community members who voice opinions. Changes to Ethereum come through Ethereum Improvement Proposals, EIPs, open documents anyone can write. These proposals are debated, tested, and refined. Only with broad consensus do they become reality. This model is not fast, it is not always smooth, but it is transparent, open, and inclusive. Vitalik himself is not a dictator. He is a guide, a voice among many. Ethereum thrives not because of one leader, but because of many stewards, all contributing to a shared vision. But governance extends beyond code. It lives in culture. It breathes in values. Ethereum's ethos of openness, permissionlessness, and decentralization is its true compass. These principles shape how upgrades are made, how conflicts are resolved, and how the network grows. Looking ahead, Ethereum faces big questions. How do we keep decentralization in an age of powerful institutions? How do we balance innovation with safety? How do we ensure inclusivity on a global scale? There are no easy answers, but there is faith in community, in cryptography, in the power of transparent systems. Ethereum's future is not just technical, it is ethical, it is human, and that is what makes this story more than code. It is a movement, a canvas, a garden we tend together. From its humble origins in Vitalik's Whitepaper to its present-day ecosystem of builders, dreamers, and validators, Ethereum has become a beacon, a place where logic meets values, where trust is earned by math, and where the world is reimagined one block at a time. So now, as your eyes grow heavy and your thoughts begin to drift, remember this: the blockchain is not asleep. It hums quietly, it works honestly, and somewhere across the digital ether, a new contract is being written, a promise for a more open world. Good night, dear listener, and good morning, decentralized future.